Well, here's our two objectives. I can solve proportional applications of tips, tax, percent change, discounts, and markups. And I can solve simple interest problems. But the first one we've done already. The second one is just a formula that we just plug values in and then solve for whichever one it wants us to solve for. All right, so the percent proportion right here. Remember, we got two fraction lines that are equal. One of the fractions always has to be out of 100 because it's percent, which is per 100. And so whatever the percent they give us, we would put over the 100. If they don't give us a percent, then we'd have the x there, and then we can use fish method to solve this. The other thing we need to notice when we're reading these is which one is a part or which one is a whole. For me, I generally look for the whole because it's everything. It's a total. It gives you everything that's being represented in whatever data or category that they're looking at, okay? So it's usually 100%, which we can see relates, 100 is on the bottom, per 100 on the bottom, so the other ratio is per all of it, which is 100%, all of it, right there. And then the percent we're looking for is generally part of whatever we're looking for. So this is the way we set up our problems. If we can set these up, then we can use fish method to solve them, which is what we've been doing in the past. And since we like it enough, hopefully, once we get it set up, which is the hard part, after that, after we get it set up, then it goes pretty good. So we saw one that was kind of like this last time. But like I was saying, we'll probably expect to see problems like last time on today's assignment as well. So if we have those down, then this should go pretty well. Your gross earnings were $2,269.23. You had $186.08 automatically deposited into your retirement savings. What is the ratio of retirement savings to gross paycheck? I guess you or her or whatever. Okay, so ratio, at least for now, I'm going to say let's make this a fraction. And the fraction relates to the to word. Okay, so all we got to do is look at the labels, and then we'll insert whatever values they give us for those labels. So that it first starts out the ratio of her or your retirement savings. Okay, so retirement savings, it appears to be that $186.08. That's your retirement savings. So that's going to be our numerator in this case, $186.08. You can label that, but it's not necessary that you do. Then, that is retirement savings to the gross paycheck. And it says gross earnings, but paycheck as well. $2,269.23. So that would be the second part of the ratio, $2,269.23. Now, do understand that this is our ratio. And with the decimals, I'm not going to worry about simplifying this, but it could, just be careful. You have to read and reread these several times to make sure that you're doing it in the right order. It's not always the small number to the big number. Depending on how they word this, it may switch in that, okay? But that's the ratio, and that's what we're going to go with there. Now it says what percent of her gross paycheck was, or what percent of your gross paycheck is your retirement savings. Okay, so we have that ratio, which is actually going to be a part of our percent proportion. Okay, so we know the percent proportion. This fraction is always over 100. What we just do not know right now is the actual percent. Okay, so using the percent proportion here, 1, 2, 3, 4. Let's see if we can fit that in there. Multiply, divide, and then equals. So always start with the letter, go straight up or down. In this case, I got to go down to 100. Cross up to 186.08. Swing it back down. I'm going to have to make it a little bit smaller there. $2,269.33. And then it should end, as usual, on the letter or the unknown, which in this case is X. Okay, so this is now set up for us to put this into the calculator. So I will do that. Okay, so I've got a pretty ugly decimal. They gave me this decimal right here. 8.199 7. At least, I mean, this is what my calculator is showing me. Okay, now it didn't even say that we needed to simplify it, or round rather. I'm gonna still label that as a percent. I'm going to round though to the nearest tenth, or 1 decimal place, that's the 1. To the right is a 9, which is 5 or more, so we're gonna have to add 1 to the 1 in the tenths place value, meaning this ends up being rounded 8.2%. Okay, so there's some kind of automatic deposit that goes into the retirement savings. It's about 8.2%. All right, then it says what percent of the gross paycheck was not put into the retirement savings? Okay, yeah, that's it, yep. So, as usual, you would start with 100% of your gross. And we can just look at the percentages. So this is gross right there. And then we got to take away whatever was put into retirement. I made it. So there we go, minus the 8.2%. And this will tell us how much was left or not put into the retirement savings. So yep, that's going to be 91.8%. All right, you paid $140 for an item that was originally priced at $590. What percent of the original price did you pay? Round to the nearest tenth of a percent. Okay, try this one out. Take a minute to try it out, then we'll go over it. So it is asking for percent, so we will expect the percent proportion. So we're going to make two fractions that are equal. Remember, it's always out of 100. If they were to give us a percent, we'd put that over 100, but it says what percent, meaning we don't know. So I'm going to use the variable x for that value, okay? Because the percent always goes above 100. Okay, so it says, what percent of the original price did you pay? So it does use the word of here, of the original price, which also would indicate that we're looking at the whole price, or the whole value of the item, which it says the original price item was $590. And the whole, or an original, I guess, we can put here in the denominator, $590, which means that $140 is just a part of the value, okay? Because you're not paying whole value, you're only paying part of the value, which is, in this case, $140. And the part always goes in the numerator of that second fraction, okay? So clean this up, and this is our percent proportion, which now we are ready to solve. So we should be multiplying we should have four values. Multiply, divide, and equals. Start at the x, go straight down to the 100 to make the tail of the fish. Cross back up to 140. Swing it back down to the 590. And then end where you start always, which should be where the letter is. So we take this and we plug this into the calculator. And again, this is, it gave me this ugly decimal. And now I have that labeled as a percent, but it does say specifically to round to the nearest tenth of a percent. That's 1 decimal place, so that's going to be the 7 in the tenths place value. To the right is a 2, so the 7 will stay a 7. And we end up with 23.7%. Now, if you make $35,000 a year and receive a cost of living increase of 2.5%, what will your new salary be? Take a minute, try this one out. So on this one, and there's a trap in this question, and it's this: what will your new salary be? Most students will stop by finding the actual salary increase. That's very normal, okay, because we're not used to being like, oh, I've got to still do an extra step. But on these types of word problems, especially with the percentages, they're generally going to do that. It's like saying that it's like a tax problem, right? They'll usually say, what is the tax? And then they'll usually have a follow-up question like, what was the total amount with the tax, kind of thing. But this one just jumps right into that second question, which is why we got to be careful on that. But it does include a percent, so we're going to use the percent proportion again, which means it's always going to be out of 100 right here. The percent always goes above 100 because percent means per 100. So on this one, they did give us the percent of increase, which is 2.5%. Now, again, I don't need the percent symbol with that because it's already showing per 100 in the fraction. And that represents the cost of living increase. So we'll make it the COL increase as a percent specifically, okay? Then it says up here, it says if you make $35,000 a year, that's your whole salary right now, okay? So that $35,000 a year, that is the whole salary.
So that goes on the bottom?
Correct. So we got the 35,000 here on the bottom. And again, that's your whole salary. The numerator of that second fraction will represent the dollar value of your cost of living increase. The problem with that is that we don't know what that value is. So that's where our X will go for this one. And that sets up this problem to find, again, when we find this, it's going to help us to find the cost of living increase, but not the actual new salary. I mean, it's going to help us find that, but we got to get there. So multiply, divide, equals. So again, I would go down to 35,000. Swing this back up to 2.5. Divide it by 100. Then I end where I start, which should usually be at wherever the X is. Okay, now, it looks like most of you had put this in, and you did, in fact, get the same number I did, which was 875. But again, the danger here is to say that the answer is $875, but, which, I mean, on an exam, depending on how much this question's worth, you can get some partial credit for that. But once again, this is only representing the dollar amount cost of living increase. So what we need to do is go back to the original salary of $35,000, and it's going to increase. So we're going to add that value of $875. And this will tell us the amount of the new salary. That's what we're looking for, the new salary. So 0 plus 5 is 5. In the tens place value, 0 plus 7 is 7. Hundreds, 0 plus 8 is 8. Drop the 5, drop the 3, boom, new salary. We did it. Use this information to find the new price, round to the nearest cent. Okay. All right, so we have an original price with a markup of 25%. Now, markups are going to work like either tips or taxes, where they will add on to whatever the original price is. So you have to pay this amount, but then you're going to have to pay the markup as well in order to find whatever this new price is, okay? So this means that, like a business, they'll purchase things wholesale. Maybe this one costs $85.34, but then they want to make a profit of around 25%. Of course, they have to pay bills and stuff like that too. But besides that, this one is referring to a percent, right? So let's set up a percent proportion, always out of 100. One of them should always be per 100, and the 100 tells you that you're dealing with the percent because percent tells you that it's a per 100. So the percent that they gave us was 25. If they didn't give us a percent, then we'd have to put an X there. We would have to do it. Next up, it tells us the original price. Okay, so this is an original price is the whole price. Everything is based off of the original. Okay, so if they didn't give us an original, then we would have to have an X down here. But the original is the same as the whole. Okay, everything is based off the whole, which always is in the denominator of that second fractional. $85.34. What we're looking for is this X. Now this X is not the new price, right? Up here, they say what we want is the new price, but that X is not the new price. This is just the dollar value of the markup.
So you add that to that 85?
And just to emphasize that, the 25 is the percent of the markup. Okay, so there's always should be some kind of correspondence with your numerators and denominators. The numerator is percent markup and then dollar markup, okay, because we can compare these across. And then the denominator is 100% of the price, I guess. And then the second denominator is the original or whole price. So we're ready to solve this then with the fish method. 1, 2, 3, 4 values, multiply, divide, equals. Okay, so I'm going to take the x, go down to the 85.34, cross back up to 25, swing it back down to 100, and where I start, which is always at x, and we'll put this into the calculator. Okay, so this is how much the markup is. $21 and, well, we got to round this. It did say to round to the nearest cent up here, so we're going to round to the 2 decimal places. To the right is a 5 or more, so we're going to have to add 1 to that 3. So the final markup for us, rounded, is $21.34. Okay, now again, this is how much the price increased from the markup, just like it would with a tax or a tip or something like that. But with this $21.34, we have to go back to the original price of $85.34. Okay, because this is our original price. If we were to add, because it is a markup, so we are going to add the dollar value of the markup, $21.34, which again is the dollar value markup. Then we will have the new price. Okay, so $106.68. Once again, this doesn't change. Let's say instead of markup, they said tip. Okay, like if you wanted to add a 25% tip, then again, it's not necessarily a new price. It's like the price with the tip. Okay, and the same thing is true if they were to say tax as well. Markups, tips, and taxes work exactly the same way. Of course, you want hopefully the tax isn't 25%. Otherwise we need a new Independence Day, I guess. But if it doesn't matter what numbers they use because it's a math class. So how realistic is a 25% tax? I don't know, depending on what you're doing. Yeah, so here's a tax, right? So the sales tax rate for Salt Lake County is 6.85%. What is the state sales tax on a $26,000 car in Salt Lake County? Try this one out. See if you can find out. Now again, think about what they're asking. Otherwise, you may answer the wrong question, right? So think about that. To me, the sneaky part on this one, especially after the few problems that we just did, this does not want the final price of the car, right? So again, you got to be careful which question are you answering. This one just wants the amount of tax on this car. So let's set up a percent proportion, always out of 100. They did give us the percent, 6.85%. So this is the amount of this is the percent of the tax, which is 6.85. Okay, so that sets up that first fraction for us. Of course, the 100 is always there. But then they say that the car, the overall value or the whole value for this one. So that's the whole value of the car, right? What we're looking for is a partial value of the car, which would be the tax. And so we're going to put that 26,000 here in the bottom, meaning we don't know the dollar value of the tax. Okay? All right, so we set this up once again with some fish method ready to go. Multiply, divide, and then equals with the 4 values. Let's see if I can do a better division sign. From X down to $26,000, cross up to 6.85, swing it back down to 100, and where you start always, which should be where the X is. And when I put this in the calculator, this will tell us the amount of the tax, which was $1,781. Now again, you just need to be careful because even on a problem like this one, they could say, well, what was the final price of the car with the tax? In that case, you would add this $1,781 to the $26,000, just like we did in the last problems, but we don't need to for this one because it just asked for the tax. So percent change can be found a couple different ways. The way that I usually do it is this way. But you could use this way. There are a lot of students that like this. They can find a percent of change. Once they know the percent of change or whatever the percentage is, they can subtract 100 from that, whatever. Now, on the assignment, from what I remember, it has two different boxes. One where you have to say if you have a decrease or increase. Sometimes they'll just tell you if it is or not, which is pretty easy to tell, okay? Because if your original value is bigger than your new value, that means you went from something big to something small, and so there would have to be a decrease. Okay, if you start with something small and then end up with something bigger, then it has to have been an increase. Okay, now that may seem like common sense, but you just may see this on the assignment where you have to say it's an increase or decrease, which is usually just a visual check. But these formulas, okay, so what we need to find the percent change is the amount of change that has occurred, and then we divide that by either an original or starting value. That's it. Multiply that by 100. Why are we multiplying this by 100? Because that's going to move the decimal 2 places to the right, which will tell us the actual percent of change. Okay, but this method right here won't tell you specifically if you have a negative or positive. This should always come out positive because you're taking big minus small. You have to know if you have started with an increase or decrease. Okay, but again, find the amount of change. How much has it changed from an original value to the new value, or vice versa, depending on which one's bigger, and then divide it by whichever value you start with. So there is some reading that's involved here for some of these problems, and you just to understand which value you're starting with or which one's the original. Okay, so find the amount of tax and the tax rate, round to the nearest hundredth of a percent. Okay, so the tax is essentially a percent of change on this one. The tax rate here is a percent of change. So what we need to do, right, because in our fraction where we're going to multiply by 100, this will give us the percent change. What we need is the amount of change, and then we're going to divide that by whatever the original amount is. Okay, so it says you have a cost of an item is $108. That's how much you're going to have as an original, or I guess we could say starting value, it doesn't matter. But 108 is the original value, $108, okay? The selling price is $124.12. So this would be after a tax. Now, it does also ask for an amount of tax, which we will find. So to find the amount of tax, we're going to take the selling price. That's with, this selling price is with tax. So we're going to take that $124.12. And to find the amount of tax, we're going to subtract the original price of whatever this is, $108. Now, if you like the 0.00 there, that's fine. But this will at least tell us how much the tax was, which is also the amount of change. So, I should probably be able to do this in my head, but I'm not going to, just because I know I'm going to make a mistake. $124.12 minus $108. If I can type that in correct, shows us that the amount of change is $16.12. That means that this is the amount of tax. Okay, so the change or the tax is $16.12. When I put this into the formula for my percent of change, which again, hopefully this makes sense. If you were to take the 1612 and divide it by 108, just multiply it by 100. Again, this ratio right here will tell us kind of the decimal percentage of whatever the change is. But then multiplying by 100 changes it into a percent for us. Okay, so we do 1612 divided by 108 times 100, enter. Oh, we got a fairly ugly decimal. It did say round to the nearest hundredth of a percent, so I got 14.9259. That may repeat. don't know if it does, and I don't care, because we're just gonna round this to the nearest hundredth. That's where the 2 is. The 5 to the right is gonna make that add 1 to the 2, and we end up with 14.93%. And this, that in green right there, that's our tax rate. And then we found the amount of tax here in blue. Last thing, of course, increase or decrease. It didn't ask for this, but of course the tax is always an increase. Okay, so this one, we're going to identify whether it's an increase or decrease, which the last one didn't. This one it is. Then find the percent of increase or decrease. If necessary, round to the nearest 1/10 of a percent. Try this one out. See if you can do it. Then we'll go over it. Okay, so what I'm going to do first, because it does say we want to just identify if it's an increase or decrease. The original or starting is 160, doesn't say what it is, and then the new is 90. That means it went down. Since it went down, that means we are looking here at a decrease first. Now again, that should be like its own box that you gotta just, it can be like a drop down, multiple choice kind of thing. Just say if it's an increase or decrease on the assignment. And then we can figure out the actual amount of, or percent of increase or decrease. Now, I will start with the amount of decrease. So what we're gonna do is just take the original, since it's already bigger, and then subtract the smaller value of 90. I don't have these lined up because we're just putting it in the calculator, but that's a difference of 70. So it went down a value of 70 right here, okay? And that means that in our formula, we're going to take the change. Now it did go down 70, but I don't need to know that it went down for the change. It just, the change was 70. Doesn't matter if it goes up or down. And then we will divide that by the original. Original, or again, you could say starting if you wanted to, but it does say that that is 160. All we got to do is take that, multiply it by 100, and this will tell us the actual percent of change. Now this one, it did say to round to the nearest 1/10 of a percent.
It said if necessary.
Yeah, if necessary, right? So this one with the percent, it came out on my calculator as 43.75. And this is okay as a percent. It did say if necessary, right? So this one has more place values beyond the 1/10 of a percent. So yeah, I would round this one. The 7 to the right is a 5, means we'll add 1 there. And that ends up being 43.8, rounded to the nearest 1/10 of a percent. That is the percent, in this case, of decrease. If 90 is increased to 92.7, the increase is what percent of the original number? Try this one out, then we'll go over it. So on this one, 90 is increased to 92.7. So remember, what we want to find first is kind of like the amount of change, right? So in this case, I'll just put number. How much did it change? Okay, so to do that, we would take the big one, 92.7, and subtract the small one, 90. And that tells us it changed by 2.7. Now, it did go up. It did say it was an increase, and that's okay. When we're finding the amount of change, we don't really care if it goes up or down. But it did go up. But this one's really asking how much did it increase right here. So 90 to 92.7 is 2.7. I guess that's another way to do it right there. But how much is it increases or even decreases, both include subtraction, because we need to know how much it has changed. So this one changed by 2.7. So in our formula, for percent of change, where we're going to multiply it by 100, the amount of change needs to be here in the top. And we already know that changed by 2.7.
Can we put the 90 underneath?
Yeah, so what was the original? And this is where you got to be careful. You got to read this very, very clearly, or original, or I guess starting, right? So,
That's 90.
yeah, it starts with 90. So that has to go on the bottom right here. Now, when I did this, it gave me exactly 3%. There was no need to change or round this at all. It just came out 3% is That's the change, the amount of the percent of change on this one. The last objective that we saw was a simple interest formula. So it's I equals PRT. I don't know of any like fancy ways to memorize this. It's just PRT, principal rate time. Okay, so what is principal rate and time? So the rate, of course, is going to be some kind of percentage that they give us. The principal is how much you put into, this is usually some kind of account, and or even maybe even some kind of debt, it could be, okay? So principals, whatever the starting value is, the rate is a percent. Okay, now this percent that they give us, this needs to be the decimal value of the percent. So whatever your percent is, you can always divide by 100, or you could just use the percent button on the calculator, and then it will just change it to a decimal for you. Time is calculated in years. Okay, so the principal times the rate as a decimal, and then multiply that by the time, will tell you how much interest has been put into the account. The interest does not tell you the final value of the account. So you have to be aware of that, because they may word these in that way where they're going to say how much is the final value of the account, but some of them are going to say how much interest was put into the account. And you have to know the difference between the two so that you know which one you're solving for. Now just be aware, sometimes, so they're not always going to say, well, how much is the interest or how much is the final amount of the account. Sometimes they'll say, what was the principal? Well, what was the rate? What was the time? They'll give you, of these four values, they'll usually give us three, and then we got to solve for the missing one. Something like that. Here's our formula. I equals PRT, principal, rate, time. It says you invest $6,000 in a savings plan that pays 3% per year. What will the account balance be at the end of the first year? Okay, so it gave us all three values. First, the principal. The $6,000 is how much we're going to invest at the start. Okay, so the P value, the principal, is going to be 6,000. Now I'm going to put this in parentheses just so that we know we're using multiplication here. The rate, it says that it's 3% per year. Okay, now 3%. What we need this to be is a decimal, so you'd move the decimal 2 times to the left, and you'd get 0.03 as a decimal, which we need. Okay, so that's going to be 0.03. The time on this one is just asking for 1 year, and that may not have been so obvious at first, but it's just a 1 right there. Okay, and this, when we get this all multiplied together, is going to be the amount of the interest. Now, is this question asking for the amount of interest? It's not. It's asking for the actual account balance at the end of that first year. So whatever we get in the interest, we will have to add to that 6,000. So I'm going to put this in the calculator, and this will tell me the amount of interest, which I guess I'll make red. Okay, so the interest amount is $180. That's what I got. Now, what we're going to do is we're going to take the starting value, which is $6,000. And in order to find the final account balance, which is what it wants, we're going to have to add the interest.
So we add that to the interest?
Yep, which is $180. When we get that added, we get $6,180. That is how much will be in the account at the end of that first year. Now again, you just got to be careful. This one asks for the account balance. Sometimes they'll just say, what was the amount of the interest after that first year? In that case, we could have ended right here at the $180. But this one wanted the final account balance. So you got to take the starting value, add the interest, and then we get that. Then we get the $6,180. Now you invest $13,000 at 5% simple interest for 3 years. If the interest only accrues at the end of 3 years, how much is in the account at the end of the 3-year period? Okay, try this one out, then we'll go over it. Okay, so we're going to invest the $13,000. That's how much we're going to start with, which means we're looking at that being the principal. So we'll replace the principal with $13,000 there. It did give us the rate at 5%. Now again, 5%. is like 5/100, which means you'd move the decimal 2 places to the left and make that 0.05. So our rate is 0.05. And then the time here, it says it's for 3 years. So the t, we're going to make a 3. Now, once again, all this is going to do is give us the I value, which is the interest. And when I put this in the calculator, we got 1,950. Okay, so after 3 years at 5% interest, simple interest, you have now made $1,950. So now that's the interest part of it. Once again, this one was asking specifically for the amount in the account
Can we add that
after
to
the 3 years.
13,000?
Yeah, so yeah, we're going to take the principal, which was $13,000, and then we're going to add the interest at $1,950. When we get these added, we will know how much is in the account after 3 years. So 0 plus 0 is 0, 0 plus 5 is 5. You could put this in the calculator as well. Yeah, $14,950. That isn't how much is in the account after the 3 years. Find the simple interest on a loan of $25,500 at 6.1% interest for 10 months. Now remember, the time is in years. Try this one out. We'll still go over it, but think about how that works. If this one's only for 10 months, how is that going to relate to the time being in years? Try it out. So the fact that this one is in months is crucial, because you're going to see stuff like this not just on the assignment, but usually on exam. So we do know the principal, right? We're going to start, this is a loan of $25,500. Now that's our principal. It's our starting value, $25,500. Okay, the rate, pretty clear, 6.1%. But again, we're going to take this decimal, move it 2 times to the left, and we end up with 0.061. Because we do need the rate as a decimal, 0.061. The time is is kind of the breaker on this one. It says it's for 10 months, but the time is always going to be in years. But where this one is now in months, we have to take the 10 months, but 1 year is 12 months. It's 10/12 right there. And so the interest, we have these 3 values multiplied together. When I put this in the calculator, it actually came out to the nearest penny anyways. It says that the interest amount after multiplying these is $1,296.25. So that's how much interest has accrued in this account at 6.1% interest after 10 months. So there's our 2 objectives, right? We see tips, tax, markups. I guess we didn't really see discounts, but percentage change kind of stuff, and then simple interest problems. We have it all down, and hopefully we're ready to go then.